We're going. Okay. 5.3, standard deviation. I'm going to make a new video for this because what I got recorded from previously, we're not doing anymore. That was, we were using graphing calculators to calculate the standard deviation. It's got an app in there to do that, and that was when we used to have a full set of those in a classroom at a different school. We don't have that here. So we are going to do it using some software from the internet. So in other words, it's going to be easier. So this is the most common statistical measure. Okay, you can't take an entry-level statistics course without knowing about standard deviation. So after, of course, the arithmetic mean, which most people call average, but now we know there's more than one average. There's a range, there's a median, there's a mode. Okay, after that, standard deviation, a symbol. Greek letter sigma, that's a symbol for standard deviation. So I gave you this, I think, maybe, I don't know. Calculate the mean, the arithmetic mean, i.e. layman's terms, the average of these three numbers. We know how to do this? Yes? Now if those were marks, what could you say about this person? If someone got 10% on a quiz, 50% in a quiz, and 100% in a quiz, I would say they're improving for sure. But what's the word here? That's an incredible range, isn't it? I mean, what kid does this? It's not very common. But we know how to calculate the mean. We would add all three numbers. 10 and 50 is 60, and 100. We would go 160, divide by the number of numbers, and that would be their mark after these three quizzes, if that's the only thing they've done, of course. So nothing else to weight it with, but that would be their mark on their report card, 53.3%, okay? So I use the word range. This person is not very consistent. There's another word for consistency. Standard deviation. By the way, there's a symbol for mean. X bar, this is called. Okay, so what is standard deviation? And I'll show you that in a sec, but I wanted to do this part first, because our calculator will also calculate the mean for us too. Standard deviation. Right off the top of my head, without looking up the true definitions, of course I'm not a PhD in statistics, measure of dispersion about the mean. So we've got a mean. You have an understanding of arithmetic mean or average. We know that's pretty widely dispersed about the mean. And it's really hard to talk about this without referring to our good old bell curve. Have you heard this term, bell curve? In theory, that's what the class is supposed to look like. In historical times, traditionally, that's what has happened. Okay, you've got a few A's, right? You got a few more B's. On the other end of the spectrum, depending on what country you are in, maybe that's an F, maybe it's called a D, okay, unfortunately. And then you've got all these people in the middle. And this is what should happen. Most of the students should be, i.e., average, and have an average mark. Right? Now, as a teacher, normally, this is usually what happens. You have a whole bunch of kids with B's and A's, and a whole bunch of kids with, well, you know, just the bare minimum. That's all I want. I just want to get credit for the course, just want to pass. And you don't typically get many kids in the center. Okay, bell curve. dispersion about the mean. If this is where our mean is, all right, how widely dispersed is it? Is it possible to have a class that looks like this? Everybody's got a C plus or a B. One kid's got an A, one kid's got a C minus. Yeah, that happens, right? So that's what standard deviation is. So let's calculate it. It's going to be easy. Either on your laptop or on your phone, you're going to bring up standard deviation calculator, and this website we need to use in particular, okay, just so that we're consistent. And this is the one I'm showing you, but I mean, I'm sure there's dozens of them out there. That's the one we want. Standard deviation calculator. Math is fun. Well, you can argue that, but that's just the name of the website. All right. And here it is. It's a calculator. It's going to do it for us, okay? We're not going to get the big fancy formula, but I'll show you it in a sec. If you take this at university, college level, then you're going to probably be made to use this formula. You can't cheat and use this calculator here. I need to flip this laptop around. So I'm going to get rid of number 10, comma, no spaces, the next number, 50, comma, 100. Okay, 3 numbers. Notice, look down here, there's the mean. That's the arithmetic mean. Okay? Make sure, by the way, this is clicked on population and not sample. Unfortunately, there's more than one standard deviation. I'm not going to get into the difference here. We're just getting an introduction to this. But again, if you delve into this a little deeper, you take this in a higher level, you're going to look down here. These different formulas, it's telling you which one's different. Do those look a little intimidating to a Math 11 student? Okay, so that's the actual formula. That's what you'll probably get if you took it at college or university. But it's just telling you there's a difference, okay? Don't worry about it. We're going to use population. And again, I don't even know if that's an argument that someone could have if they had a master's degree in statistics. But whether this is right or wrong for these 3 numbers, I'm going to argue that's the population. That's all of the numbers, all 3 of them at this point in time. So even though it seems like it might be a sample, we're going to use population. Okay, so just click on that. That's the only one we're going to use. But what does this say? Standard deviation 36.8. Just round it to the tenths. Don't write out all these numbers. Okay, and again, that is a dispersion about the mean. That's a pretty large number, 36.8. Okay, so standard deviation for these numbers is 36.8. So I'll just give you one more so we can compare it. If you got, let's say, marks of 62, 62 on the next one, and 62 on the third one, what would you say? You can't be any more consistent than that, can you? Right? And obviously, I don't need to do this. The mean, that's what your mark would be as well, right? 62%. If you don't believe me, add all those up, divide by 3, you'll get the same number. Any guesses what the standard deviation is going to be here? That is, like I said, as consistent as you can possibly be. You can't get any more consistent than that. So let's see. 62, 62, 62. Again, there's the mean. Of course, the range is 0. What's the standard deviation? 0. There is no variance here. There is no dispersion about the mean. It's 62. So in theory, of course, you can't get a number lower than that, okay? The higher the number, the less consistent it is. The smaller the number, the more consistent it is, and it can't get any smaller than 0. Okay, theoretically, that's as low as it can go. That is, like I said, as consistent as you can possibly be. Okay, that's it. That's an understanding, very basic, of standard deviation. Okay, we're not going to get you to write down the definition. That's not what we do here in math, but all I want, if I'm giving you a quiz, is just know how to enter that stuff on your calculator, on your phone, or your laptop, and just know how to use this program. Okay, just plug it in. We're not going to do this big honking formula down here. Okay, so it should be some pretty easy marks for you. Okay, and the knowledge of knowing that it's a measure of consistency, just like range was, but this is even more so. So just a couple of questions, should be 15-20 minutes tops, important in statistics.